I'll be demonstrating TurboPy, a specialized solution for accelerating cloud data platform modernization. The biggest hurdle in moving to Snowflake or Databricks is the lift and shift trap. Legacy ETL pipelines like Informatica or DataStage are often black box that end up costing users tons of money and time. TurboPy refactors this into fully pushdown enabled cloud-native SQL. As shown here, we automate pattern detection and logic conversion, reducing migration effort by up to 55% and significantly lowering post-migration processing cost. This is our TurboPy migration suite. From the sidebar, we can select between Informatica and DataStage as a migration source. For today's demo, we will select Informatica. We also have an option to select between Cortex, which is a Snowflake native AI, and external AI like Gemini. For this demo, we'll select Llama as an intelligence model. We also have a validator, which works after the SQL is generated to check for any errors. Before starting a demo, we'll first run a mapping in Informatica and extract its XML file. The mapping that we have chosen is retail order fact. As you can see, we have two sources and two targets and multiple transformations like aggregator, expression, router, etc. Now I'll run this mapping in Informatica. As you can see, the mapping is successful. The target tables have the necessary data. Now I'll extract the XML mapping. Now let's start the demo. We will upload the XML file. Once uploaded, you can see that multiple tabs have opened. First, let's look at the Generate Business Process Summary. This is an AI-powered summary tool, which when clicked, will try to decode the business intent behind the mapping. Like you can see, it has established the objective of the mapping. This helps us gain an understanding of the mapping. First is the Overview tab. It gives us a basic summary about the sources, targets, and transformations present in the mapping. As you can see, we have 15 transformations with there being around 8 expressions in the mapping. The Global Architecture tab provides a high-definition, draggable graph of the entire pipeline. This replaces the need to open Informatica just to see the DAG flow. Next is the Metadata Explorer. In the Metadata Explorer, we can inspect every port, the sources, targets, as well as the transformations. You can see for a joiner, we can see the join type, the join condition, also the input and output port types. Next is the Flow DAG. I can see exactly what is the upstream and the downstream, ensuring the logic chain is unbroken. Now the SnowSQL tab. When we click Execute SnowSQL Generation, the LLM calls get started and the SnowSQL generation process has begun. Now we'll wait for the SnowSQL to get generated. SnowSQL generation has been completed. We have a primary SQL and an audited SQL, which corrects any syntax issues present in the primary SQL. Now I'll copy this SQL and run it in Snowflake. Has been generated, we will run the query in Snowflake. As you can see, we are first creating the stage. From this stage, we have our two tables which are getting data inserted. FCT order transaction and ERR invalid orders. After both the tables are created, we will drop the stage. CT. As you can see, we have 30 rows generated. Informatica also has 30 rows. Now let's verify one of the order detail ID. For now, I'm choosing order detail ID 4. As you can see, for order detail ID 4, order ID is 18, product SK is 18. 18. The date key is 2023-03-19. And it was a weekend. 1 Customer SK is 18. Total quantity is 3 and total value is 411.2. Now for the second table, we have 10 rows and we have 10 rows here. Let's select one of the rows randomly. Row number 7. We have order detail ID 35. The corresponding one is this. Order detail ID is 35, order ID is 14 and product ID is 2015. The quantity is 3 and the unit price is 21.79. 21.79. Total value is 65.37. And customer ID is 114 and it was cancelled and the order date is 5/18. Now let's look at the second mapping. This is a bit more complex, having around 40 components. As you can see, we have 4 sources and 6 targets in this mapping. Now I'll run this mapping, and once succeeded, we will check the targets and export this mapping. Generate SQL for the XML file that has been exported. Once the XML file has been uploaded, you can see that we have 40 nodes with 26 transformations. Now let's generate the SQL. I have pasted the generated SQL. As you can see, we have a router-based overall status, following which we have multiple tables like target region-wise audit, latest customers, discount expired, and filled transactions. We'll run the complete query. Once that is done, we'll verify the output for one of the tables, target latest customers. As you can see, we have 15 rows generated here, and this is the output from Snowflake. This is the output from Informatica. We have 15 rows here. Let's select a row at random. Let's select row number 6, which is customer ID 111. This ID belongs to Mia Harris, who lives at 258 Snowflake. She has one order. Okay, now let's move on to the second. This is router on behavior. I'll copy the audited SQL and we will run this. I have pasted the query. As you can see, we have router on behavior stage, and from that we are creating 2 tables. One is target low customer profile and one would be target high customer. Let's run the query. Now let's check the data of high customer profile. As you can see, we have 12 rows generated and we have 12 rows generated here. Let's look at Ella Green, who has customer ID 119. She is from United States and has saved $6,427. She has 3 transactions today and is a high profile customer. Now let's look at one of the low profile customers. We have 3 such customers who are low profile. Let's look at Ethan White. He had a total saving of $178 and he had 1 transaction today. An additional feature of py is that it not only supports NoSQL generation, but it will also help you create DBT models for your XML or JSON mappings.